Hello everyones. In this quick presentation, I'd like to explain what Lisp is not. Lisp is not a functional language. Lisp is not an object-oriented language. Lisp is not a procedural language. Lisp is not even a multi-paradigm language. And this because Lisp is not a language. The reason being that Lisp has no syntax. Lisp has two syntax levels. The reader syntax level and the devalcompile syntax level. The reader syntax level is about transforming sequences of characters into S expressions. For example, a sequence of characters enclosed in double quotes is read as a string literal. Here the string contains the text "Hello World." The sequence of characters 3.14 instead is read as a number. The sequence of three characters FOO is read as a symbol, the symbol named foo. In Lisp, variable names and even what in other languages are keywords are indeed symbols. More interesting is the following case. An open parenthesis tells the reader to start building a list, and a closed parenthesis tells the reader when the list is complete. A list is a sequence of other values. In this example, the list contains three elements. The number ones, the symbol named bar, the string literal containing the single character X. A value inside a list can also be another list, so the reader is recursive. In this last example, the sequence of characters represents also a list of three elements, where second and third elements are also lists. The reader syntax level is quite similar to what in other languages is tokenization. However, the output of the reader is not a linear sequence of tokens, but is a tree. I've added an asterisk in this slide, because indeed the reader supports also some special notation to be able to build a general graph, and not only a tree. Lisp also has another set of language rules, the evalcompile syntax level. In this syntax level, the rules are about how to see an S expression at a semantic level, when either evaluating or compiling to machine code. In this example, we see a list with three elements, the symbol plus, the number 1, and the number 2. The evalcompile syntax level rules say that, in this case, the symbol plus is the name of a function to call, and the numbers 1 and 2 are the arguments to pass. Therefore, the evaluation of this S expression will return the value 3. This is a slightly different case, as the second element of the list is now a symbol. The evaluation rules say that in this case that symbol named X is a variable, so the result will be the sum of the current value in that variable with the number 2. This is yet another example, in which as you see the third element of the list has been replaced by another list. The evaluation rules say that in this case the third element should be evaluated, thus returning twice the current value stored in the variable named y, and then add to this the current value of the variable named x. Not every list is just considered a function call. For example, in this case the first element of the list is the symbol named if. This is sort of a special symbol and has a different meaning. The evaluation rules say in this case that the list is a conditional expression and must have 3 or 4 elements. The second element is an S expression to be used as test. The third element is an S expression to be evaluated only if the test returned true. The fourth element, if present, is an S expression to be evaluated only if the test returned false. Note that only one of the third and fourth expressions is going to be evaluated, not both. This is why the whole S expression cannot be considered just a function call, and the elements just parameters as they're not unconditionally evaluated. There are also other special forms, where the first element of a list is, so to speak, a keyword. Without going through all of them, just note that in this example the list begins with the symbol named defun, that is a shorthand for defined function. In this case, the result of the evaluation is interesting for a side effect, not for the value it returns. After the evaluation of this form, a new function named square will be present in the system. Okay, I can hear you saying, if Lisp has two syntax levels, one similar to tokenization and another with certain rules about evaluation, why did you say that Lisp is not a language, that Lisp has no syntax? This is a very important point. The reason is that neither of those two syntax levels is fixed. They are just predefined syntax levels, and programmers can customize and change completely both levels. The reading level can be customized by using read tables. For each character there is a Lisp function that is called to do the reading. For example, the character double quote is by default associated with a procedure that reads a string literal, and the character open parenthesis is by default associated with a procedure that reads a list. The code can, however, install a different function for a character, thus changing the tokenization rules. Here you can see a very simple example of a customization of the read table. I won't describe all the details of the code, but just discuss the general idea. Very often in an application there are configuration parameters or settings. These parameters in the code could be just variables, but you also need to read them at startup and save them when they're changed. And in general, it would be helpful to have every access to a parameter clearly marked and handled in the code. The library function setMarcoCharacter here is used to install a custom handler for the $sign character. This custom code will be called from now on instead of the default handler, that is just reading a regular symbol. The handler itself is in this case a very simple anonymous function. This function will just ignore the $sign and return an S expression with two elements, the symbol named parameter and the result of reading subsequent characters. The following line is an example of the use of this new reading rule. Without the reader macro, the name $speed would be just a regular variable name, with no extra semantic attached to it. However, with the new installed handler, the result of the tokenization will be in this case different. Any access to a symbol with a name starting with a $sign is now replaced by an S expression to which we can assign any semantic we like. In a language like, for example, C++, the handling of parameters could be implemented by having a singleton named parms and then accessing fields of this singleton. While this of course would be possible in Lisp too, it's important to note that there are substantial differences. For example, that each time you add or remove a parameter, your whole application, or at least any part using any parameter, would need recompilation. Here we're just establishing a new reading rule for our project. Parameter names are just marked with one single extra character dedicated to this. It can be a good choice or a bad choice. As always, it depends. However, this is a choice you can make in Lisp, and that you cannot make in C++, where tokenization rules are fixed, and the $sign cannot be used at all except in string literals. Evaluation syntax level can also be customized, and this is done using macros. Consider, for example, this statement when. It's like a conditional, but instead of having two expressions to evaluate in case of test passes or fails, it has multiple expressions to be evaluated only if the test passes, and does nothing when the test fails. The when statement is already part of common Lisp, but if it wasn't predefined, it would be very simple to implement. Here we see a possible implementation. Defmacro is a shorthand for define macro, and tells the system that a macro named when will take an S expression as first parameter, named here test. The macro also takes a second parameter, that is a sequence of S expressions named here body. The definition of the macro in this case simply returns an if conditional statement that defines its semantic. As you can see, after the macro substitution took place, the statement has been reduced to an if conditional, and the body has been placed inside the when true part. Please note that in this presentation, a lot of technical details have been left out for the sake of brevity and simplicity, but the fundamental point remain. Lisp is not a language. The reason is that Lisp has no syntax, in the sense that most other languages do. Lisp systems normally come with two predefined syntax levels, one for reading and another for evaluating. However, a Lisp programmer is free to modify these, shaping the language to better suit their needs. Most programming languages allow implementing solutions by creating new abstractions in the form of functions or data structures. Lisp can certainly do the same, but it also allows abstracting new syntax forms, and even the tokenization can be customized. Any character in Lisp source code can mean anything the programmer needs it to mean. Lisp is a meta-language with which programmers can shape a language to solve the problems they face. The video has been made by Andrea6502 Graffini. The voice has been synthesized by Kokoro, a very nice lightweight and easy-to-use text-to-speech engine that you can run locally. I hope this presentation has been informative. Of course, constructive comments are very welcome. Bye and see you next time.